So today what we're going to talk about is word problems with exponential functions. So these are our applications. So we're going to do compound interest, we'll do compound continuously, we'll do growth and decay, and we'll do half-life. So we have these formulas. You're going to have to memorize these formulas. They are from last year. So we have the compound interest formulas. It's A equals P times 1 plus R over N raised to the NT power. A, so this number here, is the final amount. It's your ending amount. So that's the amount you want in the account after a certain amount of time. P is the principal. That's what you invest. That's what you start with. R is the rate. The rate must be expressed as a decimal. So remember, to express as a decimal, you move the decimal 2 places to the right, left. N is the number of times it's compounded per year. So if it says semi-annually, that means 2 times. If it says quarterly, that means 4 times. If it says monthly, that means 12 times. And if it says daily, that would be 365. And then the last thing is T. T is time in years, the number of years. So let's take a look at the first example. Michael deposits $500 in an account that pays 5% interest compounded quarterly. Okay, so we have this compounded quarterly here. How much will he have in the account after 15 years? And then it says, how long will it take for his investment to triple? All right, so let's do the first part. So he deposits $500, so that's your P. My interest is 5%, so that means that's 0.05. Compounded quarterly, so my N is 4. We want to know how much is in the account after 15 years, so I'm looking for A. So A equals 500 times 1 plus 0.05 over 4 raised to the 4 times 15. So that you could just plug in. Just plug the whole thing into your calculator. So when you plug the whole thing into your calculator, you get 1,000. So we'll have $1,053.59. Okay, so let's take a look at the next part. So it says how many years, that means we're going to be solving for T, if we want his investment to triple. So that means we want our ending value to be triple of his beginning value. So I want that to be 1,500 equals 500 times 1 plus 0.05 over 4 raised to the 4t power. I'm looking for t. All right, so we're going to divide both sides by 3. Divide by 500. And we get 3. So I have 3 is equal to, I'm going to add that inside the parentheses, 1.0125 raised to the 4t power. Now I'm going to log both sides, so it's log 3 equals, this is going to go in front of the log, 4t log 1.0125. Divide both sides by log 1.025. So it's 4t equals, so plug this into your calculator, log 3 divided by log 1.025, 1.0125, and we get 88.43715,195, and then divide both sides by 4, and we get 22.1, so it will take 23 years for his investment to triple. Okay, so let's look at the next thing. All right, so the next one is compounded continuously. All right, so here's the formula for compounded continuously. It's A equals P times E to the RT power, so I call this PERT. A is your final amount. P is the principal, just like before. These two are the same. R is your rate, just like before. T is the number of years. Remember, E is a number. It's like pi. We don't plug anything in for E. We just use E on the calculator. Okay, so let's take a look at the problem. A total of $15,000 is invested at an annual interest rate of 9%. Find the balance after 5 years if it is compounded continuously. So if it says compounded continuously, you have to use this formula. All right, so they're investing $15,000 times E raised to the 0.09, and I want to know how much is in the account after 5 years. So just plug that into your calculator, and you get $23,524.68. All right, so now let's do the next part. It says how many years, so we're going to solve for time, will it take for his investment to reach $50,000? All right, so I have A is now $50,000. That's what I want in the end. The investment didn't change. R is still 0.09, and I'm looking for T. All right, so I'm going to divide both sides by 15,000. So 50,000 divided by 15,000 is 10/3, equals e to the 0.09 t. So remember, when we have base e, we use ln, so we ln both sides. So ln 10 over 3 equals, this will go into the front, 0.09 t ln e. And then I'm going to divide both sides by ln e. Oops. So ln e both sides, divide by. All right, so we have ln 10/3 divided by ln e, and we get 1.203972804 equals 0.09 t. Divide both sides by 0.09. And we get t is 13.3, so it'll take 14 years for his investment to get to 50,000. Okay, so let's take a look at the back. Okay, so the next formula is growth and decay. So that's A equals P times 1 plus minus R raised to the T power. So it's plus if it's growth, it's minus if it's decay. So I have A is my final amount, P is the initial population, R is the rate, and T is time. So let's see what it says. Tony bought a brand new car for $25,000. As soon as Tony drives off the dealership parking lot, it depreciates by 10.25%. How much is the car worth when he drives away from the dealership? Okay, so let's see. We have A equals 25,000 times its depreciation minus 0.1025, and it's raised to the first power because now you want to know your time is in years. So as soon as you go away from the dealership, your time has started. So that now rounds to 1 year. So just plug that into your calculator. And obviously you can just plug that all in at one time. The car is now worth $22,437.50. All right, so let's take a look at half-life. Half-life is the half-life of a radioactive substance is the amount of time it takes for half of the substance to decay. So that's A equals P times 1/2 raised to the T over H power. So A is the final amount, P is the initial mass, what you're starting off with, H is your half-life. That would be given to you, or if you had to find it, T is time. The half-life of a radioactive element is 25 years. So this would be your H, 25 years. The initial mass is 10. Write an equation of the exponential function that models the radioactive decay. All right, so we have A equals, the initial mass is 10 grams, times 1/2, 1/2, raised to the T over 25, because that's my half-life. How many grams of substance are left after 40 years? So A equals 10 times 1/2 raised to the 40 over 25. All right, so that you could just plug into your calculator. And that would be 3.2987, and I'm going to round that to nearest 10. So 3.3 grams. How many years will it take for only 1 gram to be left? So I'm going to change, now my A is going to be 1. Equals 10 times 1/2. I'm looking for my years over the half-life. So divide both sides by 10. So I have 1 over 10 equals 1/2 raised to the t over 25 power. So now we can log both sides. So it's log 1 over 10 equals t over 25 log 1/2. Divide both sides by log 1/2. All right, so I have t over 25 equals, so plug log 1 over 10 divided by log 1/2 into your calculator, and you get 3.321928095. Put that over 1, cross multiply, so multiply by 25. So it's 83.04 years. So it will take 84 years for the mass to become 1 gram. Okay, so that's it, and we'll practice in class. Have a good night.